So in this problem, we are taking type 6, the nth derivative Leibniz theorem we are going to apply for the successive differentiation. So here you can observe y value we got it as what, e power minus 6 into x square sine hyperbolic function 2x. So the thing is that x square you can take it as u, there is no problem. What about v? E power minus 6 into sine hyperbolic function 2x. That is quite complicated, right? So what we can do, we can just simplify those two terms. So first thing what we can do, whenever you're getting hyperbolic function, that can be converted into what, exponential function. See, we have studied that type of problems before also. So let us see how to convert. As we know that sine hyperbolic x can be written as e power x minus e power minus 6 by 2. The same concept we have to apply here. In place of x, substitute what? 2. So y will become e power minus x into x square is there. This particular thing I can write it as e power 2x minus e power minus 2x by 2. Simple. Now this 1 by 2 can be taken outside. Then everything you multiply inside. What will happen? Y is equal to 1 by 2. Then e power minus x into this thing. So what will happen? E power minus x square e power 2x minus e power minus x square e power minus 2x. Simple. Now here we need to understand that e power minus x and e power 2x, you can simplify it. What will be? Base is same, powers can be added, right? Here also powers can be added. You will be getting the answer as what? Y is equal to 1 by 2 into e power x into x square minus e power minus 3x into x square. Simple. Now we'll find out the nth derivative. How to find nth derivative? Which is given by 1 by 2 into nth derivative of e power x into x square minus nth derivative of e power minus 3x into x square. Now as we have discussed that previous problem also, what we can do, 1 by 2 into this thing, we have to take what, Leibniz theorem separately, because here also u into v, here also u into v. The thing here is that u has to be taken always a polynomial. Here x square, both the cases it is same polynomial we have to consider. Okay, that is fine. So let us consider how to do that. So we'll see the formula again. Formula for Leibniz theorem we can see over here. In this particular formula, what you can observe, that you need to find uvn, nc1, u1, vn minus 1. So u here it is what? This has to be considered as u, this is v, this is u, and this is v. So u here both the cases is what? X square. So we'll write u as what? X square. Now u decides till where the formula will go, right? Till which term we have to write. What is u1? u1 is basically 2x, differentiation of x square is 2x. What is u2? u2 differentiation of 2x is what? 2. And u3, how much will be getting? Constant differentiation. 2 differentiation is what? 0. So what you understood? So means u3 I cannot consider, because that entire term becomes 0 then. So till where I have to consider? I have to consider till this point. So the thing is that I can eliminate other parts in the Leibniz formula, right? So other things I'll eliminate. So the answer will be till here, this much. So this much thing we have to find. So I have to find separately, because here also uv, here also uv. That both the things separately I have to find, put it over here and here, minus those things and multiply with what? 1 by 2. Simple concept. Let us find. So first function I'll consider here. We have to find the nth derivative of e power x into x square. Here u is this one, v is this one. We'll first find out what all things has to be found out. U is already there. Vn I have to find. Nc1 is already, the value is n. Okay, nc2 value how to find? Nc2 is basically, okay, we'll see that also. So u value is x square. u1 is 2x. u2 is 2. Done. Next. V value is e power x. So what is Vn? Nth derivative of e power x is what? E power x only. Because when you differentiate e power x n number of times, you will be getting e power x only, right? So Vn is e power x. What is Vn minus 1 and Vn minus 2? Vn minus 1 will be wherever n is there in the function, there you have to put n minus 1. But here there is no n only, so it will remain as it is. What is Vn minus 2? Again it will remain as it is because there is no n term only, right? Now what about next term? Nc1, Nc2. Nc1 directly you remember it is n itself. Okay. What is Nc2? NCR formula we are having, which is n factorial divided by n minus r factorial into r factorial. So what happens to Nc2? Nc2 will be how much? N factorial divided by n minus 2 factorial into 2 factorial. What is 2 factorial? 2 itself. N factorial can be rewritten as n into n minus 1 into n minus 2 factorial divided by n minus 2, because n minus 2 and n minus 2 cancel, here 2 is sitting. So the answer will be n into n minus 1 by 2. Simple. If you want, if you are doing practicing this thing, you can directly remember nc2 is n into n minus 1 by 2. That's it. Okay. So all the things we got in the first thing. Okay. So now we can write the nth derivative of this thing. So the nth derivative of this particular problem, nth derivative of e power x, or first I'll write the first function as x square. That will be better because first function as x square into e power x, that particular function. U is there, Vn is there. So U is x square into Vn. Vn value is e power x, right? Plus nc1 is n into u1. U1 is what? 2x into Vn minus 1 is again e power x. Okay. Plus then nc2 value is n into n minus 1 by 2. Then u2 value is 2. Okay. So this 2 and this 2 gone. Then Vn minus 2 is what? E power x again. Okay. So simplified version you can write it as x square e power x plus 2nx into e power x plus n into n minus 1 into e power x. Done. So this particular part we go. Now we'll go for the next particular thing, this next function. Okay, this function will go. So u is this one, v is this one. So we have to find u. U we know already, x square. U1 will be 2x. U2 will be 2. Next, v value will be e power minus 3x. So what about Vn value? Now the problem is there. What is the problem? When y is equal to e power ax, then nth derivative, because in place of beside x someone else is sitting. Who is sitting? Minus 3 is sitting. So the nth derivative of that is a power into e power ax. This is the formula. So same applies here. What is a value? Minus 3. So minus 3 power n into e power minus 3x. This is the nth derivative. We have to find Vn minus 1 as well as Vn minus 2. So in place of n, I have to substitute what? What? N minus 1. So what will happen? Minus 3 power n minus 1 into e power minus 3x. Next, n minus 2, what will happen? I have to substitute n minus 2. Where I have to substitute? In place of Vn, you substitute n minus 1. Okay, this equation, not the previous one. So minus 3 power n minus 2 into e power minus 3x. So we got n minus 1 also, n minus 2 also. Now, nc1 and nc2 values we already know. nc1 is how much? And nc2 is how much? N into n minus 1 by 2. Is equal to u value is how much? X square. Vn value we found out, e power, sorry, minus 3 power n into e power minus 3x plus nc1 value is n. U1 value we know it is 2x. Okay. Vn minus 1 is minus 3 power n minus 1 into e power minus 3x plus nc2 value is n into n minus 1 by 2 into u2 value we know it is 2, so 2 and 2 gone. Vn minus 1 value is minus 3 power n minus 2 into e power minus 3x. So the simplified version will be going to do, we got two separately functions. Now we have to combine those two, right? So between minus sign is there. So 1 by 2 I can multiply with both. So it will become 1 by 2 into this thing minus 1 by 2 into this thing. So combining both. So yn becomes what? 1 by 2 into first function derivative take what? E power x, e power x, e power x. Common is there, you can take it outside. Second thing, you can take e power minus 3x common. If you want, otherwise you can leave it here also, there is no problem. But still will do. So yn becomes what? I'll take e power x outside. So e power x by 2